It's okay. It is what it is. C'est la vie. So we're going to be talking about linear relations today. So a relation is an identified pattern or relationship between two variables. So as we did on, what was it? Thursday, we talked about positive correlations, negative correlations, and constant correlations. When it comes to linear relations, they're going to have either of those three. So it can be a constant, a positive, or a negative correlation. So graphs are an important tool in analyzing the relationship between two quantities. So we're going to consider the example. So the first one we have is the test scores versus the hours of study time. So what general conclusion can we gather from this graph over here on the left between the hours, the number of hours studied versus the test scores? What can we conclude from this graph? Maya.
The longer you study, the higher the mark.
So longer you study, the higher the mark.
Yeah, it's going up.
Yep. So I don't know what human being studies for 35 hours, but sure. Is this a positive or a negative correlation or constant?
A positive.
Yeah, it's a positive correlation because it's going up. And you know what? Some people may argue, I don't have to study a lot, I'll still get high marks, which is true. But in this study, the general consensus was the longer you studied, the higher your marks were. So how about this one over here? We have our grade point average versus the hours of video games played. So what can we conclude about that?
I don't understand. Wait, which is great? Which is video?
It's a negative correlation, that's fine. But what can we say about the amount of video games played versus your grade?
More video games you play, worse your grade is?
Yep. The more video games you play, the worse your grade is, which is sometimes not true. Okay? Yep.
Yeah, it is a negative correlation. Yep.
So more games played, the worse you do. The worse your mark. And then we have other examples here which have to do with weekly salary and the number of cars washed. We have number of games rented versus the total cost. So as you can see, those are both positive correlations. Obviously, the more games you rent, the higher you have to pay. The more cars you wash, the more amount of money that you're going to get. Okay, so it's nothing too tricky. Like I said, it's either going to be positive, constant, or negative correlation. When it comes to linear relations, because of the word linear, you're never going to have a correlation that doesn't exist. So it's either going to be the three, positive, negative, or constant. It's going to be the three of them. So before we move on, I wonder if you guys have heard this before. Independent variable. You probably heard it in science. And dependent variable. Have you guys heard of this in science? Okay. So can someone come up with a definition for an independent variable? Anyone? How would you best describe an independent variable? Gian.
Variable which has no bounds.
Okay. Anyone else? It does change. Anybody else? Do you have your hand up? No. Okay. Okay. So your independent variable in math helps you determine how it affects your dependent variable. So this affects your dependent variable. So if we look at the number of games rented and the total cost of those games, What happens as you rent more games? How does it affect your total cost in that case? Matthew,
Goes up.
it goes up. Okay.
It's buying more, it's the rental more.
Mm-hmm. So, what would you say the definition of a dependent variable is? Dion? Yep. So, your dependent variable depends on what your independent variable is. Hence the word dependent. So, for example, let's just take the example of me working and the amount of money I get paid. Does my money depend on the amount of time I work, or does the time I work depend on the money I make?
The first one.
Yeah, the amount of money I make depends on how much I work. Okay, obviously, teaching is salary based, but for someone who's working part time or works hourly, the amount of money depends on how many hours you work. Okay. See if you guys can copy this down.
Just from my face.
Okay. So, what is a linear relation? So, a linear relation occurs when a relation between two variables appears as a straight line when graphed on a coordinate plane. So, we learned about last week, we learned about scatter plots where you would have to make a line of best fits. So, this is called a scatter plot. I'm going to draw it here. So, scatter plots, hence the word scatter. Your points are scattered randomly, but they may have a correlation. So, what type of correlation would this have? This scatter plot, positive, negative, constant, which one? Yazin? Positive. Because if I draw my line of best fits, remember it has to pass through some of the points, but be of equal distance from each of the other points. So this has a positive correlation, and I have to make a line of best fit. Okay, with my linear relations, my line of best fit passes through all of the points. And the reason why it passes through the points is because we are able to create a linear equation or expression when it comes to plotting these points. So remember, say these are my points. Because it's a linear relation, my graph is going to pass through all of the points. Or my line's going to pass through all the points. So that's the key difference between a scatter plot and a linear relation. A scatter plot, you draw a line of best fit that passes through some of the points, but a linear relation, your line passes through all of the points. I'm going to write down here, so your linear relation, your line passes through all points. Through all, underline, points. So that's how you can distinguish a linear relation from a scatter plot. Is your line has to pass through all points. So again, on your x-axis goes your independent variable, and on your y-axis goes your dependent variable. relations, we're still going to be using algebra, but algebra in the sense that it's going to represent a pattern for the line. So again, we were talking about the dependent variable. It's a variable that is affected by some other variable. In this case, it is affected by the independent variable. So this should be page 3 on your handout. It should say 3 at the bottom. So basically, when you have data for two variables, you can look at a relationship between the two variables. You have your independent and dependent, and one represents the x, which is the independent, and your dependent represents the y-axis. So for example, when it came, so this is going to be your y, this is x. When it came to, let's say, hours worked versus salary or money paid, which one did I say was on the x-axis? Was it my money or my hours? Which one is on my x-axis? My pardon? Hours is my x. So usually time is going to be on your independent variable, so the x-axis, and everything else is going to be on your y-axis. Yes.
So your dependent variable would be on your y-axis.
Mhm.
Your independent would be on your
Yep. Because your dependent always changes depending on what happens with your independent variable. So like if I work no hours, I'm going to make no money. But if I work longer hours, I'm going to continue to make more money. Or if you're a big spender, for example, if you have like $1,000 in your bank account and you like spending $5 per week, eventually you're going to hit zero, right? Because the amount of money depends on how long you're spending that money for. So with that, so if you're spending money, would that look like a positive linear relation or a negative linear relation? Claire? Negative. Thank you, Danka. Negative. It's okay. So for example, let's say Sean's big spending. That's what I'm going to call it. So here he has his time in weeks, and here he has his money left. So he's going to start at $1,000, which is over here. Let's go down. Let's say this is 500. Remember, I'm just making a scale, so it might not be accurate. So 1, 2, 3, 4, 5, 6. So he spends X amount of money per week. Eventually, what's going to happen is as I keep going downwards, there's going to be a certain week where he hits nothing, where he's completely broke. But obviously, Sean's never going to reach that point because he's a smart man and will be good with his money. Correct?
Correct.
Perfect. But yeah, but if you have like a bank account with money that you just want to spend and you spend X amount of dollars per week, you're eventually going to hit $0. Okay. And you can actually come up with an equation, a linear equation for this. But if I were to describe this in words, I would say Sean starts with $1,000 and he spends, let's say, $50 every week. And this would be represented by the graph. So that's how Sean's spending would look like. So this is going to be a negative correlation. So I'm going to zoom out and then you Let's move on. So again, I'm not going to go over the independent variable again. Like I said, it's usually time or amount of things sold or anything to do that's going to have an effect on your dependent variable. So we have two terms, nonlinear and linear. Can you guys come up with a definition for both of these guys? Pretty simple one. What does it mean to be nonlinear? Not a line. And linear means a line. So I'm going to label these graphs 1, 2, 3, 4, 5. So which one of these are a non-linear relation? What would not be considered a line? Yazin. Number 2. Okay. Now, which one of these are considered a line or linear? Yazin. What else?
Number 3.
3. Anything else?
Number 4.
Okay. And you're missing one more.
Number 1.
Yeah, there we go. 1, 3, 4, 5. Okay. Now, these guys, you guys are gonna learn this in probably grade 10. Like this is a graph that you guys are gonna learn about. Whoops, hold on, let me draw it properly. So you guys are gonna learn about this graph in grade 10. Look at that.
Why is it on the?
Oh, because it goes into the negative y-axis.
I was gonna say.
Or even better, in grade 12. In grade 12, even better, my favorite unit is called curve sketching.
This is like art. Is this what you art?
It's cool art. I find it cool art.
It has any numbers.
You guys let's learn about that too. And of course, if I were to enable this 6 and 7, these are called nonlinear relations because they're not aligned. So you can feel free to draw those just for reference. So relations can be expressed numerically through our coordinates. So remember, when we have our coordinates, what comes first, x or y? So this is on my x-axis and the y-axis. Okay, so x comes first, then y. So we can also represent it graphically through a graph. We can represent it as an algebraic equation, which we have learned about already. And we can represent it verbally using a word problem. So in order for something to be an algebraic equation, what does it have to have? Variable and equal sign. So in this case, if we were all linear relations or linear equations, linear lines, they're going to be looking like this. So this is how it would be represented algebraically. So y is equal to 2x plus 4. So that would be considered a linear relation. Okay. So this guy in front of the x is going to be your pattern. So what do you think is going to be happening? What would the pattern be? This is going to tell you how much is going to go up or down by each time. So in this case, because I have a 2 in front of my x, what would my pattern be? Let's see if you guys can figure this one out. Is my 2 positive or negative? Positive. Which means that I'm going to be, yes, Claire? Increasing by 2. So in this case, my pattern is increasing by 2 each time. So what this 4 is going to tell me over here, this is known as my initial value. So when we have drawn a line, so if we look at the examples above, if we look at those linear relations, so if we look at 1 and 2, at what part of the axis does it start at? Remember, we look at graphs from left to right. So where does it start at? What axis is that? Nope. Yeah. So my graphs usually start on the y-axis. Okay. So that number at the end is my initial value. So this is where the graph hits the y-axis. So that is called my initial value. So for example, if we have my table of values, we have -2, -1, 0, 1. Those are my x values. And we have my y values, which are 1, 3, 5, and 7. So we can take the pair -2 and 1, and we can make those a point on the graph. So what's my first coordinate on the graph going to be? What's it going to be? What did I just put in between brackets? So my first point, remember, it's x and y. So what's my x value in the first one? -2. And what's my y value? So what's my coordinate? Wait, what are you talking about? I'm talking about the table of values right now. Yeah, so what's my coordinate? -2, comma, 1. What's my next coordinate? Okay, what's my next one? And what's my last one? Yeah. So now I can draw these on my graph. So -1, -2, 1, 2, 3. So this is my y, and this is my x. So my first point we said was -2 and 1, which is going to be right over here. My next one is going to be -1 and 3, which is right over here. My next one is going to be 0 and 5. Of course, my drawing isn't good. And my next one is going to be 1 and 7. So this is what my linear relation is going to look like. Any questions so far? So this is graphically. Okay. So we have, obviously, we talked about graphically and algebraically. So how would you graph y is equal to 2x plus 5? How would you graph that? Given what I told you guys from before. Start with the easiest, start with the last number. What does that last number represent? Yeah, where it starts on the y-axis. So in this case, where is my graph going to start at? 5. So it's going to start right over here. What's my pattern? So I'm going to make my table of values. So when my x is 0, so that's where it starts, my y value is 5. So what's my pattern? What am I going up or down by? John? No. What's the number in front of the x? 2. So I'm going up by 2. So what's my next y value? 7. Okay. So my coordinate would be 1 and 7, which is over here. What's my next y value? 2 and 9. Perfect. And last but not least, what's my last y value at 3, Sean? 11. So then this would be my linear relation or my linear line. I can extend beyond this and figure out what my y value is when x is like 4, but I can also use the equation itself. So if x is 10, what is my y value? My y value. How would you guys figure that out using that equation? Maya? Yep. Yep. So it's exactly algebra. Plug in 10 for x. So here I would have y is equal to 2 times 10 plus 5. What's 2 times 10? 20 plus 5, which is what? So what's my coordinate when x is 10? How would you represent that as a coordinate? So remember, it's x and y first. So we have my x value, Maya, which is what? You just said it. 10. And what's the y value I got? What's the value I just got when I put in 10 for x? Literally right there, someone. 25. So my coordinate would be 10 and 25. Okay. You can do the same thing. If I ask you if x is 20, what is my y value? It'll be 45. Okay, so my point would be 20 and 45. So verbally, this is a linear relation with a slope or a rate of change, or in this case, I'm using the word pattern because I'm just starting you guys easy. Pattern of 2 and a y-intercept or the initial value of 5. This easy so far, hard. So the next thing we're going to do is we're going to put it all together. So we want to complete the table of values using the given equation, plot the points, and then join them to create a line. So my equation is y is equal to negative 2x plus 3. So what would my initial value be? Pardon? Nope. Nope. Alice? Yep. Yeah, 3. So it's going to be 0 and 3. That's going to be my initial point. Because when I talk about my initial point, my x value is always going to be 0 because that's where it touches the y-axis. So what's my pattern now? No pattern. It has to do with the x. Someone? Alice? Yep. It decreases by 2. So what's, yep, 1, negative 1, negative 3. Perfect. Thank you, Matthew. So now I'm going to plot these points together. And then I'm going to come up with some pretty cool word problems. Okay, so 0 and 3, it's going to be over here because that's where it hits my y-axis. Then 1 and 1, 2 and negative 1, 3 and negative 3, and then 4 and negative 5. So that would be my linear relation. So is this a negative correlation or a positive correlation? Negative, because from left to right, it's going down. So a word problem can be, let's say, let me see, what can I come up with? This is weird. So let's say Sean has $3. It's okay. And loses $2 every day.
Why?
Because I said so. He starts with 3, loses $2 every day, so he basically owes money to the bank after like the second day. And that's not the type of graph you want to see with your bank account. Not a negative correlation.
But Sean does.
I hope I.
Okay, so next one is going to be 1. So the next thing we're going to do is we're going to complete a table of values using the given equation, plot the points, and then join them to create a line. So I'm not going to get you too worried about fractions yet. So what would my fraction be converted into a decimal? So 3 over 2 is the same thing as saying what? Which is 1.5. Okay, so again, what is my initial value? 1. So 0, 1, that's going to be my first point. Okay, what comes next? What's my pattern? Adding by. Yep, so what's next? Okay, what comes after? Okay, after that? Okay, 7, perfect. Okay, so these are going to be my points again. Did we?
Not with you.
No.
Maybe a different one.
She did
Okay, so I have 0, comma 1, 1 and 2.5, 2 and 4, 3 and 5.5. I hate these because they're so small. And then 4 and 7. So let's come up with another fun scenario. So let's go with Alice. Alice owns, you're not going to be laughing, Sean, 1.5 Bitcoin and gets, owns 1 Bitcoin, sorry, whoops, that's my initial value, owns 1 Bitcoin and gets 1.5 Bitcoin every month for free.
Wow.
Wow. That's just.
She's blessings every month.
I think Alice is the one movie.
I mean, Bitcoin's worth more than $3. I don't see why she would be mugging
It's
you.
also virtual money, so how do you borrow someone virtually? That's just
Okay. And then last but not least, I want you guys to do this on your own. Example 3, instead of negative 2x as we already did it, I'm going to change it up. I'm going to change it up to y is equal to 3x plus 5. Unless I did that already.
I think we did what he had.
Okay, never mind. 4x plus 5. Okay, which means you're probably going to have to extend your graph, but if you don't want to draw the graph, that's fine as long as your table of values is good, okay? Because the graph may be too small for this to work out. So I want you to do this. This is probably the end of the lesson. Do this. I'm going to come around and check it. So if you can't graph it, that's fine. If you can just graph the initial value, I'm totally cool with that. But do your table of values and come up with a very creative word problem. Okay. So that's it for today's lesson. And then after that, you have a chance to work on the worksheets that are on that lesson.